In the earlier video, we have covered questions on basic concept of speed, time and distance and questions on average speed. In this video, we will try to cover questions based on ratio and thief, constable and overtakes. So let us proceed with our question. So our first question says that a car travels 80 km in 2 hours. Here distance traveled by the car is 80 km and time is 2 hours, and a train travels 180 km. Okay, so the distance traveled by the train is 180 km and time is 3 hours. The ratio of the speed is, we have to find the ratio of the speed, and as we know, speed is equals to distance upon time, and both the units are in kilometer and hours, so we don't need to change the unit of the given values. So after putting the above values in the formula, we will get 80 by 2, that is 40 km per hour. Again, speed is equals to distance upon time, 180 upon 3, that is 60. So we have to find the ratio of speed of car, that is 40 ratio, and speed of train, that is 60. 20 into 2 40, and 20 into 3 60. 2:3 is the correct answer. Next question. The speed of the 3 cars are in the ratio 1:3:5. Okay, the ratio among the time taken by these cars to travel the same distance. And as we have discussed, when distance is constant, the ratio of speed and time get inversed. Or we can say that speed is inversely proportional to the time. And we have to find the ratio of time taken by the cars. So we have given this ratio of speed. The ratio of speed is 1:3:5. So the ratio of time will be 1/1 ratio 1/3 ratio 1/5. And as we know the basic rule of mathematics, that we can't put the values in ratio, we can't put the values in fraction while they are represented in the form of ratio. We can't put the value in fraction when they are represented in the form of ratio. So to make them, to represent them in the value of whole, we have to eliminate this denominator. And for that we will take the LCM of 5, 3 and 1. That will be 15. The LCM of 5, 3, 1 will be 15. LCM of 5, 3, 1 will be 15. One second. LCM is equals to 5, 3, 1, that is 15. Now we will multiply each term with 15. Then 15 into 1/1 ratio 15 into 1 ratio upon 3 ratio 15 into 1/5. So our answer will be 15 ratio 5 ratio 3. 15 ratio 5 ratio 3. Option C is the correct answer. We can't put the values we can't put the values in fraction while they are represented in ratio, and that is why we have taken the LCM of the denominators. We got the LCM as 15. After getting the LCM, we multiplied each term with 15 so that the denominator get eliminated and we get the answer in whole. Next question is, a cyclist after cycling a distance of 70 km on second day. So cyclist is cycling 70 km on second day. Okay, finds that the ratio of distance covered by him on the first 2 days was 4:5. Okay, so distance covered by cyclist on 2 days are in the ratio of 4:5. That means on first day distance covered by the cyclist is 4 unit, and on the second day distance covered by the cyclist is 5 unit. So as we have given that 5 unit is equals to 70 kilometers, 5 unit is equals to 70 kilometers. Okay, if he travels a distance of 42 kilometers on the third day, again we are given that on third day cyclist cover the distance of 42 kilometers. Then the ratio of distance traveled on the third day and the first day is so we have to find the ratio, so we have to find the distance covered by the cyclist on the first day, and for that we have to find the unit of we have to find the value of 4 unit. So if 5 unit is equals to 70, then 4 unit will be 70 by 5 into 4, 70 by 5 into 4, and that is 14. 14 into 4, 56. 14 into 4, 56. So the ratio of distance traveled by the third day and first day, the third day he covered 42 ratio, and first day he covered 56. Okay, 7 6 42, 7 8 56, 3:4. 3:4 is the correct answer. A certain distance is covered by a cyclist at a certain speed. Okay, let's say cyclist is covering x kilometer by y kilometer per hour speed. If a jogger cover half the distance, so jogger is basically covering half the distance covered by the cyclist, then the distance covered by jogger will be x by 2 in double the time. So first we have to find the time taken by the cyclist to cover the distance. Then time is equals to distance upon speed. Distance is x kilometer and speed is y kilometer per hour. Then time will be x by 2. Here time taken by the jogger will be 2x by y, because jogger takes double the time taken by the cyclist to cover the same distance. Okay, so we cover the half of the distance. Okay, then we have to find the ratio of speed of the jogger to that of cyclist. We know the speed of cyclist is y kilometer per hour, and to find the speed of the jogger we have to divide distance by time, and distance is x by 2 and time will be 2x by y, x by 2 into y by 2x. X and x got cancelled. Then the speed of the jogger will be y by 4. Speed of the jogger will be y by 4. So ratio of speed of jogger to the cyclist. Ratio of speed of jogger to the cyclist. The speed of jogger is y by 4 and cyclist is y. After cancelling we got 1 by 4 as our ratio. 1 by 4. Option A is the correct answer. Next question. The ratio between the speed of two trains is okay. The ratio of speed is 2:5, where the first train covers 350 kilometers in 5 hours. Okay, first train covers 350 kilometers in 5 hours, then the speed in kilometer of the second train. So we have given the distance covered by the first train and the time taken by the first train. From here we can calculate the speed of the first train, and the speed is equals to distance upon time, that is 350 upon 5. The speed of first train is 70 km per hour, 70 km per hour, and the according to question the unit for speed of first train is 2 unit. And we have to find the speed in kilometer of the second train. We have to find the speed of in kilometer per hour of second train. So if 2 unit is equals to 70 km per hour, then 5 unit will be 70 by 2 into 5, that is 35. 5 5 25, 2 5 3 16 17, 175 km per hour, 175 km per hour. Option A is the correct answer. We had given the speed of distance and time taken by the first train. From here we calculated the speed of the first train, put in the ratio, got the second speed of the second train, that is 175 km per hour. Next question. The ratio between speed of two trains is 2:5. Again we have given the ratio of speed, that is 2:5. If the first train runs 350 km per hour in 5 hours, okay, again the speed of first train is the speed of train 1 T1 is 70 km per hour. Then the sum of the speed, okay, and the speed of second train will be again same because all the values are same. Okay, the speed of second train will be 175 km per hour. Then the sum of speed of both the train will be 5 7 7 14, 245 km per hour. Option C is the correct answer. Next question. Ratio between the speed of two trains is 2:5. Again same, speed is equals to 2:5, where the first train runs 350 in 5 hours, so the speed of train 1 is equals to 70 km per hour. Then we have to find the difference between the speed of both. Again the speed of train 2 will be 175 km per hour, so difference will be 105 km per hour. Next question. So we have completed the questions based on ratio. Now we will move towards our new topic, that is thief, police and overtake. Thief, police and overtake. In this topic we will get familiar with a new term, that is relative speed. That is relative speed. Before jumping on to the relative speed, we will first try to understand what is speed. So what is speed? How do we measure speed? What is the parameter of measuring the speed? 1 second. what is the parameters of measuring the speed? We have solved many questions in which we have to find the speed of a particular object, and then we have used the formula of distance upon time. We have used the formula of distance upon time. So if we divide the distance and time taken by the particular object, then we will get the speed. But my question is, how do we calculate the distance? How do we calculate the distance? If we want to get the speed, then we have to first find the measurement of distance. How distance is measured. So first try to understand it with the help of diagram. Let's see point A and point B. There are 2 points, point A and point B. Okay, and a car is moving from point A to point B. Let's say if I ask you, tell me what is the distance that has been covered by the car, then you will say the distance between A and B will be the distance covered by the car. But if I don't tell you the initial point, or a starting point of the car, then it is impossible to determine the distance that has been covered by the car, because there is no starting point. So in order to measure the distance, we need to know the starting point or initial point of that object. Similarly, if we want to calculate the speed, we need to know the starting point or initial point of the object. For an example, a car is moving from point A to point B. Let's say the distance between them is 10 meter, and car takes 10 seconds to reach point B. And now if I ask you what is the speed of the car, then you will simply say that distance upon speed, 10 meter upon 10 seconds, that is 1 meter per second. 1 meter per second is the speed of the car. So if I ask you car is at point B, if I ask you car is at point B and it started from any other point, now tell me the speed of the car. Then again it is impossible to determine the speed of the car, because we don't know the initial point of the car. And if we don't know the initial point, then we cannot determine the distance that has been covered by the car. And if we can't determine the distance that has been covered by the car, then simply we cannot determine the speed of the car. So either it is distance or speed. In order to measure distance or speed, we need to have a stationary point, fixed point, initial point, or a starting point. So this was all about speed. Now we will talk about relative speed. Now we will talk about relative speed. In case of speed, we have saw that in case of speed we have seen that there was a starting point and there was a starting point and we calculated this distance. We calculated both distance and speed. While referring to that starting point or static point. We calculated distance in reference of this point. We calculated speed in reference to this point. Now what if our what if there is no static point, there is no initial point, and both the and the initial point is also moving in a certain direction. Then we use the term relative speed. If we talk about the definition of relative speed, then relative speed is the speed of an object in respect to another object. It means relative speed talks about two objects which are in motion. Relative speed talks about two objects that are in motion. Let's say it is car A and it is car B. And both are moving on a parallel track. Now let us understand it in a different way. There is a man standing here. And there is a car. There is a man and a car. Both are standing at a similar point. Now, if car is moving with the speed of 5 km per hour, then after 1 hour, the distance covered by the car will be 5 kilometers. Now we have seen that the distance of car, we find the distance of car with reference to this man. Standing on the similar point with the car. Now in the next case, the car and the man both are moving. The car and the man both are moving in the similar direction. both are moving in the similar direction. Let's say car is moving with the speed of 10 km per hour and the man is moving with the speed of 5 km per hour. After 1 hour, after 1 hour, the distance covered by the car will be after 1 hour the distance covered by the car will be 10 kilometers, and after 1 hour the distance covered by the man will be 5 kilometers. Distance covered by the car will be 10 kilometers and the distance covered by the car will be 5 kilometers. So after 1 hour, the distance between car and the man, the distance between car and the man will be 5 kilometers. Before it started move. Hello. Yes. Before this, before their movement, they both were in the same starting point. But after 1 hour, we can see that the distance between both of them is 5 kilometers. The distance between both of them is 5 kilometers. And again, in the next hour, again in the next 1 hour, the distance covered by the car will be 20 kilometers. The distance covered by the car will be 20 kilometers and the distance covered by the man will be 10 kilometers. Then after 2 hours of time, the distance between both man and car will be 10 kilometers. So we can see that the distance between both car and man is getting increased with time. So here we can say that the relative speed between man and the car is 5 kilometers as it is increasing with 5 kilometers every hour. In the first hour it was 5 kilometers, in the second hour it will be 10, and the next, if we talk about the third hour, then it will become 15 kilometers. So relative speed will be 5 kilometers. And how do we get the relative speed 5 kilometer? That is after subtracting the speed of man with the speed of car. That is 10 minus 5 is equals to 5 kilometers per hour. So it is one of the cases of relative speed. Now we will talk about another case. In this case, both the car and the man is moving in the different direction. One second. In this case, both the car and the man is moving in the different direction. Let's say man is standing here and car is standing parallel to the man. And man is moving towards east direction, and car is moving towards west direction. and both are moving in the different direction. So let's say the speed of the car is 10 kilometers per hour and the speed of the man is 5 kilometers per hour. After 1 hour, distance covered by the man will be 5 kilometers. The distance covered by the man will be 5 kilometers and the distance covered by the car will be 10 kilometers. So after 1 hour, if we calculate the distance between man and the car, that will give us 10 plus 5, that is 15 kilometers. Because man has moved 5 kilometers towards east and car has moved 10 kilometers towards west. So total distance will be sum of the distance traveled by both man and the car. So in case of opposite direction, we add the speed of both the objects. That is x plus y. So the whole summary of this story was, in case two objects are moving in same direction, then relative speed will be x minus y. And in case two objects are moving in different direction, then relative speed will be x plus y. That is sum of the speed of both the objects. So this was all about relative speed. Now we will proceed towards our question. Our first question is: a thief is spotted by a policeman from a distance of 100 meters. A thief is spotted by a policeman from a distance of 100 meters. When the policeman starts the chase, the thief also starts running. The speed of the thief be 8 km per hour and that of the policeman is 10 km per hour. How far the thief will have run before he is overtaken? So let us try to understand it with the help of diagram. Let's say this is point A, this is point B, and this is point C. So thief is spotted by a policeman from a distance of 100 meters. What happened is thief is stolen something from point A. And starts running towards B. After running for 100 meters, the thief has been spotted by the policeman. So after running for 100 meters, thief is at point B. And police is at point A. When the policeman starts the chase, the thief also starts running, and the speed of the thief is 8 km per hour. So here we have given the speed of thief, that is 8 km per hour, and that of policeman, that is 10 km per hour. Okay. How far the thief will have run before he is overtaken? So if we say that thief has been overtaken by the police at point C, the thief has been overtaken by the police at point C, then what is the distance covered by the thief? That is, we have to find the distance between B and C. We have to find the distance between B and C, and as we know, distance is equals to speed into time. As we know, distance is equals to speed and time. So we have to find the distance covered by the thief. So we have to find the time taken by the thief to reach point C. We have to find the time taken by the thief to reach point C, as we have already given the speed of the thief, that is 8 km per hour. So if we find the time, then we will easily find the distance that has been traveled by the thief before getting overtaken. So for that, first of all, we have to find the relative speed. We have to find the relative speed of both police and thief, and we have just discussed that in case both the objects are moving in the same direction, then we just subtract the speed in order to get the relative speed. Then the relative speed will be 2 km per hour. 2 km per hour. Okay. From here we will calculate the time taken by the thief. That is, time is equals to distance upon speed. Time is equals to distance upon speed, and we have given the distance in 100 meters, and we have given the time in speed in kilometer per hour. So we will first convert kilometer per hour into meter per second. That is 2 into 5 by 18, that is 5 by 9. So the speed will be 5 by 9, 5 and 9, 5, 20. So total time taken by the thief to reach point C is 180 seconds. Total time taken by the thief to reach point C is 180 seconds, and we have already given the speed of the thief, that is 8 km per hour. That is 8 km per hour. So 8 km per hour, and we have to find the distance in meter. We have to find the distance in meter. So we will first change 8 km per hour into meter per second, that is 5 by 18, 2429, 20 by 9 meter per second, 20 by 9 meter per second. Then we will put the above values in the formula, that is, this distance is equals to speed into time, and time is 20 by 9 into speed is 20 by 9 and time is 180 seconds. Therefore the distance will be 400 meters. Option C is the correct answer. As we have seen that it takes a lot of time and lot of unit conversion to get to the answer, and it is not possible in the exam to perform this much of solution in that given time. So we will first try to sort it out and have a look at a different approach for this question. Let us first erase because when you are sitting in a competitive exam, time is the main factor. And you can't ignore it. So in order to be on time, you have some tricky approaches for each and every questions. Now have a look at the diagram Let's say point C is the place where both police and thief both police and thief. Point C is a place where both police and thief are. Hello. Yes. Point C is a place where both police and thief are at the same point. So from here we can understand that the distance traveled by the police is A to C, and the distance traveled by the thief is B to C. So after traveling different distances, both police and thief is at point C. It means both police and thief take same period of time to reach point C. It means both police and thief take same period of time to reach point C, and then only police can overtake thief. Otherwise there is no possible way to overtake thief. If you want to overtake the thief, you have to be on the same spot where thief is. So from here we have concluded that time taken by police and thief is same. So as we know, when time is constant, the ratio of distance and speed also remains the same. So we have given the ratio of speed. That is, thief is moving with the speed of 8 km per hour, and the policeman is moving with the speed of 10 km per hour. So let's say thief ratio police, the speed of thief is 8 and the speed of policeman is 10. After eliminating, we will get 4:5. As their speed. Then the distance will automatically get 4:5 because the ratio are same in case time is constant. So the difference between the distance is 1 unit, because thief is covering 4 unit of distance and police is covering 5 unit of distance. From the diagram we can also see that from A to C distance is more, and from B to C distance is a bit shorter. So here again in the ratio format, the distance covered by thief is less and the distance covered by the police is more. So the difference between both of them is 1 unit. And from the above diagram we can see that 1 unit is equals to 100 meter, because thief has already taken the advantage of 100 meter from the police. So 1 unit is equals to 100 meters, and from the equation, from the ratio, we can see that the distance traveled by thief is 4 unit. So if 1 unit is equals to 100, then 4 unit will be 400 meters. Again, 400 meters is the correct answer. So from here we can conclude that shorter approach will save your time in the examination. Now we will do full postmortem of this question. Now what if we ask to find the time taken by the thief to reach point C? What if we ask to find the time taken by the thief to reach point C? Now as we know, time is equals to distance upon speed. As we know, time is equals to distance upon speed. So time is equals to distance upon speed. So in this way, we have to first find the distance. We have to find the distance first, and then putting the time, putting the value of the speed. Then we will get the time taken by the thief. So we have just find the distance. We have just find the distance like 5:4 and 5:4. The difference between the unit of distance traveled by thief and the police is 1, and 1 unit is equals to 100 meter according to question. Then 4 unit will be 400 meter. 400 meter. Therefore the distance traveled by the thief is 400 meter. So d is equals to 400, and the time taken by and the speed of the thief is 8 km per hour, and the speed of the thief is 8 km per hour. After converting it into meter per second, we will get 5 by 18. That is 20 by 9 meter per second. That is 20 by 9 meter per second. And from here we get the answer as 180 seconds. 180 seconds. So if we will ask to find the time taken by the thief to reach point C, then we will give the answer as 180 seconds. 180 seconds will be taken by the thief to reach point C. Now what if we ask to find the speed of any of them? Speed of, let's say, if we ask to find the speed of thief? What if we ask to find the speed of the thief? Let's say police is traveling with the speed of 10 km per hour, and we have to find the speed of thief, that is x km per hour. Before finding the speed, let us see one more approach to find the time. Let us see one more approach to find the time. This one is even shorter than the earlier approach. We know time is equals to distance upon speed. We know time is equals to distance upon speed, and we have given distance of 100 meter between police and the thief. We have given the distance of 100 meter between police and the thief. Therefore the distance will be 100, and speed of the, and then we will find the relative speed of both the police and the thief. We will find the relative speed of both the police and the thief. Then police and the thief will be 2 km per hour, and after changing it into meter per second, we will get 5 by 18. 5 by 18, that is 5 by 9. 5 by 9, then 100 into 9. 100 into 9 upon 5, that is 20. 180 seconds. So this is the best way, this is the best approach, or this is the best way to find the time. If we have asked to find the time taken by police or thief, then we will use this approach, because it is even more shorter than the earlier one. So we have just saw three approaches to find the time, and this one, the last one, is the shortest. This last one is the shortest one. So whenever if you are asked to find the time taken by the police or time taken by the thief, you can use this method. It will save your time. So my question to you is, why we have taken the distance as 100 meter? Why we have taken the distance as 100 meter? Because our thief got caught at point C. Our thief get caught at point C, and the distance between A and C is 500 meters. As we have already seen here, the distance traveled by the thief is 400 meters, that is B to C is 400 meters. and we have already given that from A to B it is 100 meter. Then why we have taken 100 meter as distance and not 500 meter as our distance? Let us first try to understand this logic with the help of one more example. Let's say we have two brothers, Santa and Banta. Santa is 5-year old and Banta is 10-year old. After 5 years, Santa will be 10-year old. After 5 years, that is plus 5. After 5 years, Banta will be 10-year old and Santa will be 10 year and Banta will be 15-year old. In the first case, the difference between both the brothers is 5 years, and after 5 years, the distance between both the brothers remains same, that is 5 years. In the similar case, or in the similar manner, if police is chasing the thief with the same speed, let's say police is also moving it with x kilometer per hour, police is moving with x kilometer per hour and thief is also moving with the speed of x kilometer per hour, and the distance between both of them is 100 meter. After 1 hour, the distance between police and thief will remain the same. After 1 hour, the distance between police and thief will remain the same because both are moving with the same speed. Just like Santa and Banta, they both are growing with the same speed. Similarly, police is chasing the thief with the same speed, and the thief will never get caught because the distance will remain the same. After any period of time. So basically, police is eliminating this 100 meter. Police is eliminating this 100 meter distance, of distance, in order to get the thief. After every hour, police is eliminating some distances from this 100 meter. Let's say the relative speed is 2 km per hour. Let's say their relative speed is 10 km per hour, like police is moving with 10 and thief is moving with 8, so their relative speed will be 2 km per hour. That means police is eliminating 2 kilometers every hour from this 100, or you can say 2 meter per second, right? 2 kilometer into 5 by 8 in 1 second. 5 by 9. So police is eliminating 5 by 9 meter per second from this 100 meter of distance. 5 by 9 meter per second from this 100 meter of distance. Police is eliminating 5 by 9 meter per second from this 100 meter of distance, and that is why we have taken this 100 meter as a distance, and not 500 meter as our distance, because if the police want to chase the thief, he has to eliminate this 100 meter. Of the distance, otherwise the thief will never get caught. So it was all about time, after what time thief will get caught. Now if we have asked to find the speed of, let's say, thief, Here we have given 10 km as the speed of police and x km per hour as the speed of thief. So we know speed is equals to distance upon time. Speed is equals to distance upon time. So distance traveled by the thief is 400 meter, and the time taken by the thief is 180 seconds. So speed will be 40 by 18, that is 20 by 9, 20 by 9 meter per second. And if we want to change meter per second into kilometer per hour, then we have to multiply with the fraction 18 by 5, that is 9 into 2, 5 into 4, that is 8 km per hour, as it is already given in the question. The speed of thief is 8 km per hour. So from here we can conclude that we have saw all the approaches. If we have asked to find the distance, if we have asked to find the distance, if we have asked to find the speed, and if we have asked to find the time. So in this type of questions, this is the only things that can be asked from you: the speed of the thief, or time taken by the police, or the distance that has been covered by the thief. These are the only cases that can be occurred from the above question, or all the types of question that has been asked in thief and police. So moving towards our next question. A thief is running at 7 km per hour. So the speed of thief is 7 km per hour. He is chased by a policeman whose speed is 8 km per hour. Again, here police P is moving with 8 km per hour, and here thief T moving with 7 km per hour. If the thief is 85 meter ahead and the distance between them is 85 meter ahead of the police, then the time required for the police should see. Here we have to find the time. In the earlier question we have to find the distance. Here we have to find the time taken by the police to catch the thief. Let's say thief get caught by the police at point X, and we have to find the time. And for time we have seen the shortest approach, that will be distance upon speed, and the distance will be 85 meter, and the relative speed is 1, and we have to find the time in minute, and the relative speed is in kilometer per hour. So we will first change kilometer per hour into meter per minute, that is 50 by 3. It means 50 into 50 into 3. So 117 10 17 into 3 51 by 10, that is 5.1 minute. 5.1 minute is the correct answer. So it is the shortest approach to find the time, distance, and the relative speed. That's it. You can get the answer in seconds. Again, a thief is moving with 40 km per hour. Again, they see the same condition. Thief is moving with the speed of 40 km, and this time he covers a certain distance in 5 hours and 15 minutes. Thief is moving with the speed of 40 km per hour and covers a distance in timing is 5 hours and 15 minutes. Okay, if the police is chasing him to cover the same distance, and they both are covering the same distance, let's say point X, where police and point X is the place of encounter between police and thief. So police is also chasing the thief with the same point. In the earlier question, thief has the advantage of some distance, but in this case we don't thief don't have any advantage of distance, because both police and thief are running from the same point, and point acts as the point of encounter between police and thief. And traveled this distance thief traveled this distance in 5 hours and 15 minutes. So this was the story behind the question. And the speed of police is 50 km per hour. We have given the speed of police, that is 50 km per hour. Again we have to find the time. How long will the police take to cover the same distance? As we know when distance is constant, then speed gets inversely proportional to the time. So we have given the speed of police and thief. Here we have given the speed, that is police 5:4, then time will be 4:5, then time will be 4:5. As we have given, the time taken by the thief to cover the distance is 5 hours and 15 minutes. And according to the ratio, the time taken is 5 unit. Time taken by the thief is 5 unit. If 5 unit is equals to 5 hours and 15 minutes, and here we have to find the answer in minutes. So we will first change 5 hours and 15 minutes into minute, that is 5 hours is equals to 300 minutes plus 15 minutes, that is 315 minutes. So time taken by the thief is 5 unit, and the time taken by the police is 4 unit, and we have to find the time taken by the police, that is 4 unit is equals to 315 by 5 into 4, 5 6 30, 5 6 30 once again 5 6 30 5 3 15, 16 into 4, 63 into 4 is equals to 4 3 12. Okay, 4 6 252 minutes. The answer will be 252 minutes, 252 minute. And as we know, 4 hours is equals to 240 minutes. 4 hours is equals to 240 minutes, and the remaining will be 240 minutes, and the remaining will be 12 minutes, and the remaining will be 12 minutes. Therefore answer will be 4 hours and 12 minutes. So here option A is the correct answer. Next question is, thief steal a bike at 12:30. Okay, here we have given the time, exact time when the bike has been stolen by the thief. So here the thief stole the bike at 12:30. Okay, and drives it at 48 km per hour. Oh, very less speed. But the thief is discovered after half an hour. Okay, so he's moving with the speed of 48 km per hour. That means he is covering 48 km per hour in 1 hour. 48 km in 1 hour. Then the distance covered by him in half an hour will be 48 by 2, that is 24. That is 24 km. And at 1 p.m. he will be at point B, and police is at point A. The bike owner, this time bike owner is chasing the thief. The bike owner start to chase him on another bike at 58 km per hour. So now after half an hour, that is at 1 p.m, bike owner started chasing the thief. Now now at 1 p.m, owner is at point A, and at the same time thief is at point B. But Thief is moving it with the speed of 48 km per hour, and the bike owner is moving with the speed of 58 km per hour. Then we have to find the time. Again, we have to find the time, that at what time he will get caught at. Okay, so in order to find the time, we use the method of relative speed, that is distance upon speed is equals to 24 upon 58 minus 48, that is 10. And this time we have to find the time in hours, and we have given the distance in kilometer and speed in kilometer per hour. The kilometer and kilometer got cancelled, and hour, so we will find the answer in hour, so we don't need to change the unit of the given value. So after eliminating both, we will get 2.4 hours. 2.4 hours as our answer. 2.4 hour, very short method. 2.4 hours barely takes few seconds to solve this type of questions. So 2.4 hour is the correct answer. So from 1 p.m. 1 p.m. plus 2.4 hour, that will be 3:24 p.m. 3:24 p.m. because 1 hour consists of 60 minutes. So after that we will get the answer as B, 3:24 p.m. A goods train start running from a place A, from a place at 1 p.m. Okay, again a goods train is running from a place at 1 p.m. Okay, 1 p.m. is the exact time, at the rate of 18 kilometers. So speed is 18 kilometer. Another goods train starts running at the same place, running from the same place at 3 p.m. Okay, so time is 1 p.m. and this is the time of T1, and this is the speed of T1. Again, time of T2 is 3 p.m. and the speed of T2 also we have to find the speed of T2. So from a goods train starts from the same place 3 p.m. in the same direction and overtakes the first train at 9 p.m. So let me first draw the diagram. Train 1 start its journey at 1 and train 2 starts its journey at 3. This is the train 2, and both will meet at point X at 9 p.m. So again we have to find the time speed of T2, and we have already discussed how to find the speed of any of the object in the first question. So our approach will remain the same, that the time taken by both train 1 and train 2 is same, because both of them are at 9 p.m. at point X, both of them at X at 9. This means both of them have traveled the same, both of them taken the same time to reach point X. So speed is equals to distance upon time. Speed is equals to distance upon time. So first we have to find the distance that has been traveled by train 2. For that and the time taken by, so we know that train 2 started at 3 p.m. and reached point X at 9. So the difference between the time will be 6 hours. So we have given time as 6 hours, and distance will be as both the train 1 and train 2 is covering the same distance. So if we find the distance of train 1, then we will automatically get the distance of train 2. So from here we can see that at 3, let's say at 3 p.m. train 1 is at point B. At 3 p.m. train 1 is at point B. Now leave this. Let us understand it in a direct approach, in a direct manner, that train 1 is moving for 8 hours. Train 1 is moving for 8 hours. Like train 1 started its journey at 1 and reached point X at 9. Reach point X at 9. So the difference between the timing is 8 hours, and distance is equals to speed into time. Speed of train 1 is 18 km per hour and the time is 8 hours. 18 into 8 is equals to, I think, 144. Yes, the speed of train 1 is, so the speed of so the distance that has been covered by train 1 is 144 kilometer. 144 kilometer. Then the speed, then the distance traveled by the train 2 will also be 144 kilometer, because both of them have traveled the same distance. Therefore speed will be 144 upon 6, that is 6 2 12 6 4 24, that is 24 km per hour is the correct answer. Once again, let us first try to understand the logic behind the question. First we have given the two trains. We have given that the two trains are starting its journey from same point. That means when they will meet at any point, they have covered the same distance, because both have started their journey from the same point. So if we find the distance of any of the train, then it will become the distance of the second train. So we have used this method and got the distance that has been traveled by the train 1. So this is the speed of the train 1, and this is the time of travel of train 1. This is the speed of train 1, and this is the time taken by the train 1 to reach point X. So after calculation we got 144 km as the distance that has been covered by the train 1. So as we have just discussed that both of them has started their journey from same point, then 144 km will automatically be the distance that has been traveled by the train 2. So after putting the above value in the formula, we will get 24 km per hour as the speed of train 2. So moving towards the next question, we have two trains start from point A and B and travel towards each other at a speed of 50 km per hour and 60 km per hour. At the time of their meeting, the second train has traveled 120 km more than that the first. The distance between A and B is okay. Here 2 points A and B and two trains are traveling towards each other at 50 and 60. Let's say train at A is traveling with a speed of 50 km per hour and train at B traveling with the speed of 60 km per hour. Okay, and they meet at point X. When they meet at point X, the distance that has been traveled by the train B is 120 kilometer more. If A traveled X kilometers, then the distance traveled by B will be 120 plus X kilometers. So we have to find the distance between A and B. Again, we can see from the above diagram that both of them reach point X in the same time. So when time is constant, the ratio of speed and distance remains the same. Let's say two trains, and let's say A ratio B, and the speed of A ratio B is 50 or 60, that is 5 ratio 6, and the distance traveled by them will same, that is 5 ratio 6. So we have to find the distance, total distance, that is we have to find the value of 11 units, because distance traveled by A is 5 units and distance traveled by B is 6 unit, and we have given that B has traveled 120 kilometer more. That means the difference between their distance is, according to ratio, is 1 unit, and according to question is 120 kilometers. So if 1 unit is equals to 120 kilometer, then 11 unit will be 11 into 120, that is 1320 kilometers. So option C is the correct answer. We have to find the distance, total distance, that is 5 plus 6, that is 11 units, and we got the value of 1 unit as 120 kilometer, because B has traveled 120 kilometer more. Whenever it is given that he has done more or less, he has traveled more or he has traveled less, that means there it is question is talking about the difference, question is talking about the difference. So 6 minus 5 is equals to 1, and 1 unit is equals to 120, because distance traveled by B is 120 kilometer more. Next question is, the distance between two stations A and B is 60 kilometer. Two trains start at same time from A and B, traveling at the speed of 35 km and 25 km respectively. If the trains run in the same direction, then they will meet at after what time? Okay, let us understand it with the help of diagram. That two station A and B is 60 kilometers. The distance between them is 60 kilometers, and two trains start at the same time, and both of them starting their journey at same time. A traveling with the speed of 35 km per hour, and B is traveling with the speed of 25 km per hour. If the train run in the same direction and both of them are running in the same direction, then they will. So again we have to find the time, and for time we know time is equals to distance between both the object and relative speed, that is 35 minus 25, and we have to find the time in hours, and it is already given that we have already given the values in kilometer and kilometer per hour. So kilometer per hour and one second, it is 10. Kilometer and kilometer will get cancelled, and we get the answer as 6 hours. So option C is the correct answer. A passenger train running at a speed of 80 km per hour leaves the railway station 6 hours after a goods train leaves and overtake it in 4 hours. What is the speed? Again we have to find the speed of the train. So I will leave this question for you. Do it by yourself. A starts walking at a 4 km per hour, and after 4 hours B starts cycling from the same point as that of A in the same direction at 10 km per hour. So here A start walking with the speed of 4 km per hour, and after 4 hours, that means after 4 hours, when A reaches point B, that is 16 kilometers from A, B starts cycling. Let's say A reaches point X, B starts cycling from the same point Y. B starts cycling from the same point as that of A in the same direction with the speed of 10 km per hour, and both of them are moving in the same direction. After how much distance from the starting point will B catch up with A? Let's say they will meet at point P. So both A and B will take same time to reach point P. Both A and B will take same time to reach point B P. Therefore, when time is constant, the ratio of speed and distance remains the same. So A ratio B will be 4:10. This is the ratio of speed, that is 2:5, and the distance will be 2:5. And as we can see here, the difference between the distance is 16 kilometers, and the difference in the unit is 3 unit. So 3 unit is equals to 16 kilometers. 3 unit is equals to 16 kilometers. Therefore, we have to find the distance. When B get caught. Therefore, the distance. So, if 3 units is equals to 16 kilometers, then what will be the value of 5 units? Because distance traveled by B, we need to find the distance traveled by the B from the starting point. Because we have asked how much distance from the starting point, and B is moving from the starting point after 4 hours of travel. After 4 hours of travel by B is moving from point Y after 4 hours of travel by A. Therefore, we need to find the distance of B. Therefore, 5 unit is equals to 16 by 3 into 5, that is 80 by 3, that is 26.67 kilometers, and this is the correct answer. Next question. A thief stole cash from a bank at 8:15. Again, here we have given thief stole cash from bank. Let's say it's bank at 8:15 p.m. and left on a bike at a speed of 60 km per hour. The police were informed at 8:30. So after 15 minutes of time travel, after 15 minutes of time period, that is from 8:15 to 8:30, distance traveled by the thief will be speed into time, that is 60 into time, that is 15 minutes. If we change 15 minutes into hour, we will get 1/4. Therefore, distance will be 15 kilometers. So distance traveled by thief will be 15 kilometers, and we can also say that the distance between bank and thief after 15 minutes of time period is 15 kilometers. Now at 8:30 police is at point B, that is police is at the place of bank, and thief is 15 kilometers ahead of police, and thief is 15 kilometers ahead of thief. If police want to catch the thief, if police want to catch the thief at 9 p.m., that is half an hour later. If the police wants to catch the thief at 9 p.m., that is half an hour later, then what should be the minimum speed of the police? What should be the minimum speed of the police? And we know thief is moving with the speed of 60 km per hour. So if thief is moving with 60 km per hour, in next half an hour, the distance traveled by the thief will be 30 kilometers. The distance traveled by the thief will be 30 kilometers. And as we know, police started from bank. Police started from bank. So the total distance traveled by the police will be 15 plus 30. Total distance traveled by the police will be 15 plus 30, that is 45 kilometer. And we need to find the speed. For speed, we know there is a formula, distance upon time, and that is for total distance traveled by the police is 45 kilometer, and total time is half an hour. We know our desired time is 9 p.m. And the chase has been started at 8:30. So the time period is half an hour. So half an hour 1 by 2, and 2 will be in the numerator. 45 into 2, that is 90 kilometer. Option B is the correct answer. Next question. Trains from Delhi to Dehradun departs at 10 and 10:30 am. Again, same type of question, that from Delhi to Dehradun, a train is going from Delhi to Dehradun. Two trains, one departs at 10 am with the speed of 60 km per hour, and another train that starts its journey at 10:30 am with a speed of 75 km per hour. And we need to find the distance after which both the train will meet up, or distance after which both the train will meet. So let's say this is the point where both the train meet, that is point X. This is the point where both the train meets, that is point X. So time taken by both the train to reach point X will be same. Time taken by both the train to reach point X will be same. And we know when time is constant, the ratio of distance and speed remains the same. The ratio of speed and distance remains the same. And we have given the speed of both the trains. After terminating, we will get 15 into 460 and 15 into 575. So the ratio of distance will also be 4:5. Let's say it's train 1 and it's train 2. So train 1 is moving with the speed of 10 km per hour, and after half an hour, that is at 10:30 am, distance traveled by train A will be 30 kilometers. Distance traveled by train A will be 30 kilometers. So we can say that at 10:30 am, when train A is at point P, train 1 is at point P, and train 2 is still in Delhi. The difference between the distance of both the train is 30 km. The difference between distance of both the train is 30 km. And here, according to the ratio, the difference in the unit is 1 unit. So 1 unit is equals to 30 kilometers. 1 unit is equals to 30 kilometer, and we have to find the distance. At what distance from Delhi? We have to find the distance from Delhi, that is, we have to find the distance of the second train. We have to find the distance of second train, because at 10:30 the second train is still in Delhi. The second train is still in Delhi, and hence the distance traveled by the second train will be the distance within Delhi and the meeting point. Distance traveled by the second train will be the distance between Delhi and the meeting point, that is point P. So if 1 unit is equals to 30, then distance traveled by the second train is 5 unit. The distance traveled by the second train is 5 unit, then therefore 5 unit is equals to 30 into 5, that is 150. We can also approach this question in this manner, like if 1 unit is equals to 30, then the answer should be the multiple of 30. Answer should be the multiple of 30, and in the given option only 150 is the multiple of 30, and only 150 is the multiple of 30. In this way, if you are lacking in time, then you can easily skip this step and go for this approach, when you can just solve it with the help of multiples or divisibility rule without using pen. So moving towards the next question. Oh, so this was all about thief, police, and overtake. In the next video we will cover the another type of question, that is when train crosses a man, pole, bridge, tunnel, etc. Or a train with the same length or different length, etc. and etc. We will cover this type of questions in the next video. Thank you.